All right, so today we're going to start chapter one. All right, so we'll get out the slides for this chapter. This is chapter one, and it's our very first look at data and statistics. And if we have time, we might just get a chance to look at an Excel spreadsheet. There is one in here. I just actually added one to Blackboard. If you come over here and look at your Blackboard account, you'll see that first things first, this is the Mind Tab link. This is the video I made a little while ago introducing the course. Here's your syllabus, chapter one that we're looking at now. And then the spreadsheet is called Hudson Auto. And so if we have a chance today, we'll open this up and start to look at it. At the moment, you'll see it's just a bunch of numbers. And we're going to do some interesting things with those numbers. Okay, now this is not one of our assignments, by the way. This one we're just going to work on just to get our hands on Excel and start to learn how to use it. But later on, there will be assignments in Excel that you'll be expected to send to me by email. But this one, we're just going to learn how to use it. All right, let's get this thing open. For God's sake. Yeah, this happens to me all the time. Technology lets me down on a regular basis. So let's try that again. Okay, this time it actually worked. That's nice. All right. So these are the numbers that we'll be working with, but we'll get to that in a bit. Now, first of all, this is chapter one, so there'll be a lot of terminology that we'll be introduced to. And of course, this is what you would expect in the early days of a course like this, but fairly soon after that, most of the time we'll be working on problems. Okay, this is not the kind of course we spend a lot of time memorizing terms, but there are some that we do need to know. Okay, so the word statistics. Now, by the way, the whole purpose of statistics is a very applied area of mathematics. The point of it is that we can take real world data, and it could be any data you could imagine, and use it to draw conclusions about something or other. For example, we could use data to determine if the customers of a company are happy with their service they're getting, or if a company wants to know if people would rather have other choices, for example, or there's all kinds of useful information that could be obtained from data. And so what we're going to try to do is understand the techniques that we can use to analyze the data and draw meaningful conclusions from it. So it's a very broad field of study, and everything in statistics is designed to be useful. There's nothing there that, nothing gets into the field of statistics unless it can be proven to be useful for some purpose or other. So we can use it, and you'll see it in your other classes. It's the kind of thing you can't be avoided, but it's more important than some business disciplines than others. I mean, it's especially important in economics and finance. Everything that goes on in economics is somehow related to statistics, because what they're trying to do is take real world data and understand, for example, what is the impact of interest rates on corporate profits, that type of thing. Or in finance, we want to know, for example, if let's say GDP growth accelerates, what does that do to stock prices? That kind of thing can be studied very nicely with statistics. Accounting can use it for other purposes. Accounting is not a terribly, it's not based on real world data. I mean, it is and it isn't. There, with accounting, what's happening is all this information about a corporation is coming in the door, and they're trying to make it organize it in such a way that conclusions can be drawn about the numbers. So they may use statistical techniques as well, but it's a little bit more important in economics and finance. Marketing too. I mean, a lot of research is done in marketing. In fact, when you look at products that are available in the marketplace, you probably ask yourself, why were these products made available to us and not others? Well, most likely the companies that are producing these products did a lot of research to find out what people want. And that's how they decide what to produce and what not to produce. And so a lot of this information comes from surveys, They ask the customers what they're interested in. It also helps determine what kinds of commercials end up on TV. Obviously commercials are very expensive, so if they aren't selling a product, then they're going to disappear very quickly. And then we also have areas where we're trying to analyze how efficiently we're producing our products. It could be that there are better ways of producing whatever it is we're making, and that we could find efficiencies in our production process. That can all be done with statistics. In particular, companies that produce products, especially when there's food involved, they have to make sure that the quality is at a certain level before they try to sell it. Um, like for example, there's an interesting documentary that I managed to catch on TV about a potato chip factory, believe it or not. And you'd think that in a potato chip factory, you'd find a bunch of people standing around peeling potatoes and slicing them up and cooking them and everything. No, it was all 100% done with machines. It was very, very high tech. But the interesting thing is that at the end, when the potato chips are produced, the biggest thing that the company has to worry about is that the quality is as high as possible. So what they did was they set up a system so that when the chips are ready, they come down this enormous conveyor belt, and then they're exposed to all these laser beams. And what happens is the laser beams analyze them to see if they're too dark, which would mean that they're burnt, or possibly too light, which means they're undercooked. And so the ones that are not deemed to be acceptable are sent down one conveyor belt, and the rest, the good ones, go down the other way where they get put into the bags, and then they're sold to the public. So all this is being based on statistical information from their own knowledge of how potato chips are made. And so they should be able to predict fairly well what percentage of potato chips will prove to be defective and have to be thrown out. And if they find that the number is exceeding that level, then they have the ability to stop the process and figure out what to do about it. Information systems, computer science, they all will ultimately have a lot of real world data to analyze, although they might analyze it in a different way than what we see in, let's say, economics or finance. So every discipline takes what they need from statistics and then they use it for whatever purpose they're applying it to. So statistics is a very broad field. It's used by a lot of different areas, not just within business, by the way. Of course, it's used in biology and chemistry, and I mean, you name it. Almost every discipline that involves real world data will be using statistics, but possibly for different reasons. All right, so data. Now, by the way, here's an interesting side note. The word data is actually a plural of the word datum. That's because it's Latin. Okay, so the word datum is the actual value of a single number. Let's say I'm looking at a bunch of data about temperatures, and I have a single temperature for a single day, and that would be considered a datum. The collection of temperatures would be considered to be data. Now, often you see in any writings you might come across, that's not often used correctly. In other words, you often hear people say things like, the data is telling us this, this, or that. It technically should be the data are telling us this, this, or that. It is a plural word, but often it is misused. Okay, I just want to mention that as a side note. So data represents the details that we need to analyze some real world process or other. Elements. Now, here we have some technical definitions. And these are illustrated by this graph here. Imagine that you have this data. Now, WTO is the World Trade Organization. They keep track of all this information about their members. And here, what they've done is they've organized them by nation. And within each group, we have, or for each country, we have their status. Either they're a member or possibly not. In this case, you can see that they can be a member or an observer. Per capita GDP, which means the GDP per person, and the Fitch rating. Now, Fitch, you just make a note of this somewhere. Fitch is what we call a ratings agency. that provides ratings for bonds. Now, this is really more of a discussion that you would see in a finance class, but bonds are issued by corporations and governments to raise funds. Okay, now corporations issue bonds to raise money to run their business. Governments issue bonds because they have deficits. They always have deficits. There's virtually no government in the world right now that has surpluses. They always spend more than they bring in taxes. That's just the way it is. So the way they cover their shortfalls is by issuing bonds. Now, the thing about bonds is bonds are sold to investors who expect to receive interest payments throughout the lifetime of the bond, and eventually, at some point in the future, receive their money back. Okay, in other words, now typically most bonds are issued at a price of $1,000. So if you buy a 30-year bond issued by Apple, let's say, what you're essentially doing is lending $1,000 to Apple, and you expect them to give you interest every year for the next 30 years. And then at the end of that time, you'll get your $1,000 back, as long as the company still exists. So with bonds, investors are exposed to credit risk, which means that there's always a chance that the issuers of these bonds will not be able to make promised payments in a timely manner. Okay, companies can go out of business. Governments can't go out of business, but they can run out of money too. It's a little bit different, but there's always a chance that something like this could happen if you buy a bond. So how do you know which bonds to avoid and which ones you might want to think about buying? Well, companies like Fitch provide ratings that indicate the riskiness of a bond. By the way, you've probably heard of their competitors. Their two main competitors are Standard & Poor's and Moody's. Okay, so with the Fitch ratings, what they typically do is they'll have like the ratings take the form of letters, so that AAA is the best, followed by AA, triple B, BB, B, and it goes down. And then each letter rating also has the potential of having a plus or a minus added to it to indicate that it's maybe a little stronger or a little weaker than that. So the idea here is that investors can decide which bonds to buy based on these ratings, because AAA is the safest, but that means it's the bond issuer that is going to offer the lowest interest payment of all the other bonds in the marketplace. So in other words, AAA bonds are the safest, but offer the lowest interest payments. CCC bonds are highly risky. I mean, when you get down in that neighborhood, you're looking at a company that's almost bankrupt already, but they offer the highest interest payments. So the purpose of these ratings is to give you a sense of how much risk is involved with buying a bond, and you have to decide if the interest that they're offering you is enough to justify the risk that you're taking. But at least this means you have the knowledge to know which bonds are the safest and which ones are the riskiest. Now, there's a reason why. I mean, oh yeah, some of these have minuses. That means like triple B minus means it's not quite as safe as triple B. Triple B plus means it's slightly safer than triple B. So they do have pluses and minuses, but the main rankings are these letters. So now you'll see why they're using this as one of their choices, because data can fall into one of four categories. It can be nominal, ordinal, interval, or ratio. So what's the difference between these? Now, nominal data take the form of names or labels. In other words, what they're referring to, like, is the membership. It's not a number. It's just an indication if something is true or false, if you're a member or an observer. The key detail here is that you can't directly compare these statuses. In other words, you can't say that member is greater than observer or twice as large as observer. They're just ratings of some kind. So there's no specific relationship between them. And so this is known as nominal data. Okay, so it's probably the least useful of all the different types of data that we might encounter. But for some situations, that's all that we have. Like, what if we're Apple and we're analyzing the colors of all the phones that we're selling? Among the colors, they can't be compared directly to each other. So they would fall into the same category, which means they would be defined as nominal. All right. Now, by the way, we're not going to see a whole lot of that in this class. Ordinal means that even though it's like the next step up where at least there's a ranking of some kind that you can use and at least compare them to each other. And so, in other words, if you look at the Fitch ratings, that could be considered ordinal because at least, even though they're letters, I can't, like say that AAA is twice as good as A or something like that, but at least I know that AAA is better than A. And so in others, I can rank them in some meaningful way, which was not the case over here with the membership status. All right, so that's what we mean by ordinal data. And sometimes this is very important to have it, but again, it's going to be very difficult to do any kind of statistical analysis on it. Whereas now suddenly we have these last two, interval and ratio. Now we're getting into numbers, okay? Oh, yes, and they mentioned it right here. AAA to F is used for the Fitch ratings. They can rate them or rank them from AAA to F, but you can't compare them in the same way that you can tell that 4 is twice as large as 2. We know that AAA is better than F. We just don't have any way of comparing them directly. And there's, like letter grades in a class, of course. It's the same idea. A is the best, F is the worst, okay? Interval data. These are numbers. Okay, now we're getting into the first numerical data. And you can tell not only which is greater, they're using the example of SAT scores. Not only can we tell which is greater, but we can tell by how much. In other words, Melissa is at 1985, Kevin is at 1880. Melissa not only has a higher score, but we know that her score is 105 points higher than Kevin's. And so this is now an interval variable. And then when we add one more detail to a numerical value, it can become a ratio variable where there's some specific meaning to the ratios, but also there's some kind of a zero value. So in other words, most numbers that we encounter are ratio, can fall into this category of ratio variables. So in other words, I can tell that, like I said before, 4 is twice as good as 2. A GPA of 3 is twice as good as 1.5, that kind of thing. So these are ratio variables, which most of the time, that's what we're going to be using in this class. So yeah, like here, Kevin has twice as many credit hours as Melissa. So we can go beyond just saying that Kevin has more hours. We can also claim that Kevin's got twice as many credit hours. So this suddenly is a type of ratio variable. Now, just in general terms too, some data refer to numbers and some do not. numbers fall into the category of quantitative. The others, for example, colors and flavors and tastes and anything that's not numerical could be considered categorical. Let's see. So categorical, yeah. Again, this is the kind of thing we won't be spending a lot of time with in this class. Labels or names are used to identify the attribute of an element. So they mentioned that up here in this chart. You saw that the elements, the names of the countries are defined as element names because this is how they're listed by country or how they're organized by. Let's see, where were we? Qualitative, that means it's qualitative data. Now, even within qualitative data, there can be rankings available. So nominal means they can't be ranked, but ordinal means they can be ranked, as we discussed earlier. Like the Fitch ratings are ordinal. The membership status of these countries is nominal, okay, because they're just labels. We can't directly compare them to each other, whereas at least with the Fitch ratings, we can tell that AAA is better than AA. They could, in principle, be numbers. By the way, a good example of this would be Social Security numbers. Even though they're numbers, there's really no valid comparison that you can make between them. You can't say that one is greater than another or that type of thing. So they're going to fall into that category of nominal. Whereas ages, no, that's different. You can tell if somebody's 50, somebody else is 25. Clearly, the 50-year-old is twice as old as the 25-year-old, and that puts it into the category of ratio. And yes, this is the key to this is why we kind of avoid these numbers. Appropriate statistical analysis is rather limited. There's not much you can do to analyze Fitch ratings, let's say, or WTO membership status. Now, here we go. This is the interesting stuff. Quantitative data, numbers, of course. And of course, that means it could either be ratio or interval, but we'll mostly focus our attention on ratio data. And now here's where we do have an important distinction to make. Discrete and continuous refers to the following. A discrete variable can only assume a finite number of different possible values. Okay. For example, the number of students in a class is a discrete variable because the number of students has to be an integer. In fact, it has to be a positive integer, or at least non-negative integer, because it could be 0. But it can't be infinite, okay? You can't have an infinite number of students in a class, of course not. So that, if I was analyzing all the enrollments in the different courses at Fordham, the variable number of enrolled students would be a discrete variable because of the fact that there's only a limited number of possible values it can have. But on the other hand, a continuous variable can assume an infinite number of different possible values. For example, the average commuting time of the students in a class is continuous. And now you might say, well, that has to be a positive number, doesn't it? That's true, but it can have a fractional component because this is not limited to being an integer. So in other words, the average commuting time could be, for example, it could be 32.174,154 minutes or 33.087127 minutes, et cetera, et cetera. In other words, there's literally an infinite number of possibilities here because of the fact that it's not restricted to being an integer, although it can't, the actual value can't be infinite. The number of possible values is infinite, literally infinite. Okay. So that's the distinction between discrete and continuous. Discrete, finite number of possible values, continuous, infinite number of possible values. All right, now, quantitative or always numeric, ordinary arithmetic operations are only meaningful for quantitative data. You can't add two Fitch ratings together, for example. And then they've got this box, this diagram here. I don't know how useful that really is, but now cross-sectional data. Now, this gets back to that study that we saw with the World Trade Organization. Cross-sectional data can contain many different variables, although it doesn't have to. It can have like two or one, or well, one would be kind of pointless, but 2, 3, 4, 5, whatever. But the key here is that gathered at a single point in time. Okay, in other words, let's say that we're interested the student records, by which I mean first name, last name, social security number, GPA, let's say for each name, let's say address. These are cross-sectional because there are 1, 2, 3, 4, 5 variables being collected at a single point in time. In other words, let's say we look at this class and we have, I believe, 11 people in here. Then my record would be 11 observations on first name, last name, social security number, GPA address, all observed as of today. Whereas time series data refers to data about a single variable gathered across time. In other words, for example, the price of Apple stock, or the daily price of Apple stock over the past 10 years is an example of time series data because it is observed, it's a single variable. We're looking at how it evolves over time. Okay, so the cross-sectional data is observed at a single point in time, but it may contain many different variables. Whereas the time series data is one variable, but it is observed across time. Okay, we see a lot of that in finance and economics, by the way. Let's say I'm analyzing somebody's portfolio and I'm looking at how the stocks in that portfolio have performed over the last 20 years. I'm looking at time series data. All right. And these are graphs. You see these all the time. This would be a graph. This is the average price of gas in the US per gallon from January 2012 to 18. So you can see trends in the data. Okay, you can't do this with cross-sectional data. Data can come from a lot of different sources, especially in this day and age, the internet, so much stuff is free, but some of the stuff you do have to pay for. Okay. Now, sometimes, oh, and here's some organizations like the Census Bureau has all this information about all of us. The Federal Reserve, the central bank of the United States, has a lot of data about the US economy, and a lot of it is freely available. We can download it if we need it. And other departments of the government. Um, Now, sometimes we may not have the data that we need. We may need to carry out studies like surveys. Let's say you are a company and you are producing bagels, all right? You're a chain of bagel stores, let's say, where, like Dunkin' Donuts is what I should say. Um, Dunkin' Donuts is like, we got all these different bagels. I wonder if people would prefer another type of bagel that we don't currently offer. Well, how can we find out? Well, they'll ask the customers who walk in the door, listen, what do you think? Is there another type of bagel that you'd like to see here? And what they tell Dunkin' Donuts could determine what they will offer in the future. Okay, how else can they get this information except to directly survey their own customers? All right, so sometimes the data comes from surveys. There could also be experiments, not so much in business areas like finance and economics. We don't actually conduct experiments, but in a field like psychology, you might carry out experiments. You might, for example, you may have, there were many, many years ago, there were commercials on TV where, and it's hard to know how realistic they were, but they would have people take 2 glasses of cola. They were not labeled and say, try both of these and you tell us which one is Coke and which is Pepsi. And the premise of the commercials, it was a Pepsi commercial. They were trying to get you to believe that most people who didn't know which was which would ultimately choose the Pepsi. Well, I don't know. If it was for real, then Coke probably wouldn't be around anymore. But that used to be on TV all the time. So that would be considered an experiment. Okay, you say, listen, try these and see what you think. That's a little bit different. So if you're going into marketing, you might end up studying how these types of studies are performed. And then data is expensive. They're making a point here, data is very costly to acquire, very time consuming. Now, descriptive statistics are data that help us understand the key properties of a set of data. And in fact, it looks like we do have time to look at our first Excel spreadsheet today. So this is the fictional Hudson Auto Company, and they want to know how much it costs to do a tune-up. So they gather up data on 50 customers, and they look at the cost of the parts. So now in the slides, they're analyzed, or they're set up just so you can see them all in one place. But in our Excel spreadsheet, they're organized in a column. It's you're not going to be able to get any results in Excel if you have it set up in a table like this. It looks pretty, but you won't be able to get the numbers you're looking for. Now, what they want us to do here is organize it in a very special type of table, which is called a frequency distribution. So how do you do that? Well, there's a few ways we can do it. We can start, though, by doing this. Now watch, you can follow along. This is in Blackboard. If you want to open up this file, Hudson Auto, Chapter 1. If I copy this data, let's say to column C, and if you're completely unfamiliar with Excel, that's Controller Command C, depending whether you're using a Mac or a PC, for copy, and then Controller Command V is paste. To sort, you come up here, and by the way, the two platforms are very similar to each other now. In the past, they were kind of different, but now they're close enough that it doesn't matter which one you're using. So you'll go up here to Data, sort by column C, because it has no header, by cell values. I want it to go from smallest to largest. Okay, there we go. Now, what they want us to do is organize it in a table like this. Now, there's a way we can do this very quickly, but we're going to save that for another day. What I'm going to do is quickly do this manually. And then later on, we'll use the more sophisticated approach. So the costs are here. And they would like us to organize it in ranges of values. Frequency is the number of times this happened. And percent frequency is the same thing, except it's a percentage. So the ranges they want are 50 to 59, 60 to 69, 70 to 79, 80 to 89, all the way up to 100. Okay. So we're going to do this the old-fashioned way. We're just going to count. How many are there between 50 and 59? 2. How about 60 to 69? That's 13. 70 to 79. That's 16. 80 to 89. 7. 90 to 99. 7. And then finally 100 to 109 is 5. Great. Now the total will be needed in order to do the next part. So the Excel command for that is sum. You type equals. For every Excel command, you type equals first, then you type the name of the command, and then you open the parentheses and you tell it where the data are that you're referring to. You can manually type, in this case, F2 through F7, or you can just choose it with your mouse. And you notice it is 50. We already knew that it was 50, but I just want to confirm that. So that the percentage frequency is the ratio of each individual frequency to the total. So in other words, here I'm going to put equals F2. And if you notice, by the way, if you're not familiar with Excel, each cell is referred to by a letter, which is the column that it's in, and a number, which is the row that it's in. So F2 is divided by F8. Now I can leave it like this, but then I'll have to type this command for every row. There's a special trick in Excel that we should all know, where if you put dollar signs on any reference that you do not want to change, then watch what happens. That's 4%, by the way. I can drag it down with my mouse and it fills them in automatically. So that means that saves me a lot of typing. If I didn't have the dollar signs, it would keep adjusting this cell and I'd end up with zeros and it would give me all kinds of error messages. So that's one of the clever things about Excel. If you're referring to a cell that should change, you just leave it the way it is. If you have a cell that should never change, then you use the dollar signs. Okay, so you're locking in the reference. Now, if you want this to be actual percentages, you can select it and come up here to the Home tab and hit the % button. There you go. So in other words, you can change the formatting very quickly and easily. By the way, if I want more than just whole numbers here, although in this case, that's probably not necessary, but I can easily do that by selecting the numbers. And then over here, you have increase and decrease decimals. So if I increase it, oh yeah, there you go. If I decrease it, so I can have whatever I want. And if I add these up, now, by the way, if I want to add them up with the sum command is right here. I can drag it across and it fills in what I want. Now that one, of course, means 100%. So I change this to percent and there you go. What we've created here is what I called earlier a frequency distribution. So we can look at it and answer questions like this. Well, what percentage of our tune-ups cost between $70 and $79? It's easy to do that. If you just look at the list, it's going to take forever. Look at that. How would I know? It would take me all day. So this is a way of organizing my data into something that's much more useful so that I can then use my statistical methods to draw useful conclusions about what's happening here. All right. So already we've had a chance to get our hands on some Excel. Now, by the way, I'm going to post this spreadsheet I just created onto Blackboard so you can download it and look at it if you want to after we're done. Okay, so that way you can go in and look at the commands and see what I've done. And in case you missed something or if you just want to see what I did, I'll be taking care of that. Now, the next slide, they want us to graph it with a very special type of graph. And so you can see at a glance that the most common price for these tune-ups is between $70 and $79. So how do I do this? Well, there's a few ways I can do it. Depending on whether you're interested in the frequency or the percent frequency, let's just say, to keep it simple, we're after the frequency. So I'm going to do this. I'm going to select these two columns. I don't need the total. I don't need column G. Now, there's a lot of graphs that Excel will offer me. Go to here to insert. And what you might want to do when you're first starting out is choose recommended charts to see if you like any of its recommendations. And what do you know? Right on top is the one we want. Now, you look at it and you might say, well, you know, I don't like that title. It's easy to fix it. Let's change that to Hudson Auto. Watch how easy this is. Click, slide across, Hudson Auto. Click outside, and there it is. It's done. There's all kinds of things I can change. I can change the font. I can change the colors of these bars. But the point of this, I could put labels on the vertical axis too if I want to. So I can turn this into something very different, but this is what we were after. So this is a graph of my frequency distribution. It is a bar chart, and the heights of the bars represent each of these categories. So I can see just by looking at this chart that the most common price for my tune-ups is between $70 and $79. The least is between $50 and $59. Now, I could have probably told that just by looking here, but if I have a lot of data, let's say there's 30 categories or 50, it starts to get very difficult to just look at the numbers and see what I'm after. The graph is easy. It's easy to see what I'm looking for. You know how, I mean, you all know that, you know, you learn more easily from pictures than words. You know, how they say a picture is worth 1,000 words because we're visual learners. That's how it works. Our brains pick up on pictures very easily compared to numbers. All right, anyway, so now what if we need more information than this? What if I just want to know the average cost of a tune-up? Well, I can come back here and I can go to the bottom of the actual raw data in column A. And what I can do, by the way, I'm going to insert a new column here because I'd like to put labels in here. You select the whole column, right click with your mouse and put insert. Then I'm going to type average. I want to know the average. Now in Excel, remember you type a command as equals, then the name of the command, which in this case happens to be average. Don't forget the parentheses. And I can either manually tell it that this is cells B1 through 50, or I can just swipe down here with my mouse or my trackpad, as the case may be. And that tells me what I want to know. The average tune-up costs $78.98. Now, if that's all I need to know, all the rest of this is unnecessary. But you see how that number, that one number, tells me something very important about my data. So it is considered to be a descriptive statistic in the sense that it tells me something useful about my data. Now, with that in place, now maybe that's too expensive. Maybe I'm losing money because of that. And maybe I'd like to reduce that, but as long as I'm able to get these numbers, it's my responsibility to make sense out of them. So with statistical inference, we're not trying to gather up and create numbers or numerical measures. We're trying to draw conclusions from the numbers that we have. Now, when we do this, it's very important to make a distinction between two types of data. Whether the data are numerical or not, the data can come from one of two sources. We have what's called a population, which is a set of all elements of interest. For example, if the US government is analyzing the average age of the US population in order to determine if the Social Security system needs more money, which it always does. You know, that's one of the only unfortunate side effects of people living longer and being healthier, is that the Social Security system is always going to run out of money. So they're going to, but they need to know about this far in advance. They can't just one day say, oops, we're about 100 billion short this year. What do we do? No. They have to know about it far enough in advance to do something about it. So they're going to look and say, you know, the average age is growing at this rate. At this rate, maybe the expenditures will grow up by X%. So therefore, we must set aside X dollars to make sure that we don't run out of money. So if that's the case, the population of interest is not the people in the United States, is the ages of Americans. In other words, all 300 plus million ages is the population of interest. Now, sometimes, you know, you do see the entire population is actually studied. The census that's taken every 10 years is an attempt to capture the size of the entire US population. But normally, gathering up all the information in a population is impractical because the population is very large, or it would be very expensive and or time consuming to gather up all the information in the population. So what do you do about it now? And you know, all right, well, here's what you do. Instead, we can use a sample which is drawn from the entire population. So there's a sample is a smaller portion of a population. Now, this is what you see when you look at polls, for example. Let's say you go and watch TV during election season and they're constantly bombarding you with polls after polls after polls, and they tell you 42% are in favor of candidate X. Well, you can rest assured they did not call every single voter to get that number. They used a sample. They have their methods where what they're going to have to do is pick a smaller set of people that represent the entire population. If they can do that, then the results will be very close to the results you would get from the entire population. If, that's the key thing, that's the big if. So a sample must reflect the underlying population. Otherwise, any results taken from the sample will not accurately reflect the properties or characteristics of the population. And then the results are meaningless. Okay. So, this is how a lot of information is gathered from samples. So let's say Apple wants to know what colors they should use for the next iPhone. I mean, there's a lot of colors they could potentially choose. How do they decide? I don't even know how many they have. I always just grab black automatically every time I get a new phone, but I'm sure they have other colors. Let's just randomly pick the iPhone 16 since that's the newest one. Oh my God. Well, I am startled to see some of these colors. Teal, pink, ultramarine. Oh, pink again. Desert titanium, cricket. Oh, black, sorry. And then over here we have ultramarine again. All right, so it looks like 1, 2, 3, 4, 5. Looks like there's basically 5 colors here. Well, how do they decide, or how do they obtain the appropriate information to make this decision? Well, they'll use surveys, which could be considered a sample of the entire population of Apple users. But the surveys will be applied to Apple customers who are the most likely to buy the new iPhone. So they're not going to pick people who, are too young, let's say, to buy Apples, or who are too old to have an iPhone. They're like, no, I don't want one of those things. I'm fine with my whatever I have now. So they have to be very careful how they choose these, who to send these surveys to, because otherwise they're going to get meaningless results. So as long as the samples are chosen carefully, the information gathered from these samples should provide a great deal of useful information about the underlying population. It won't be perfect, of course, that's understood, but there's always going to be some margin of error when you use samples instead of populations. But still, let me give you an example of this, how this can be very helpful. The voting age population of the United States is like more than 100 million people. When you look at these political polls, sometimes the number of people they've asked their opinion could be in just a few thousand. Well, how is this possible? How can a few thousand people represent 100 million voters? If they're chosen well, then their responses will probably give us a lot of insight into the thinking of the entire population of voters. It's all about choosing them carefully. Now, by the way, sampling is actually a very complex process. And depending on the discipline that you're in, it is done differently depending on the discipline that is using the statistical data. In other words, you'll get different approaches from psychologists than economists, for example. So, in fact, you can actually, you could take an entire semester and do nothing but study sampling methods. It's a very intense area of study. For our purposes, in economics and finance and other business disciplines too, samples tend to be random samples, which means that every member of the population is equally likely to be chosen. But you can imagine, like in psychology, what if they're interested in women's opinions about something or other? Well, then in their samples, they're going to have to be careful to only include women. Otherwise, it would be kind of pointless. So here, with statistical data in economics and finance, we tend to use these simple random samples, which means that just whatever's out there, everyone's equally likely to be chosen. It really does keep things simple. All right. So a census, now statistical inference means you're drawing conclusions. It's not enough to gather up the data and calculate measures like the mean. You have to draw conclusions from it. The census is when you're actually measuring the entire population. And a sample survey is when you're choosing a sample only. Okay. All right. Now, by the way, what they want us to see here is that oh, this is some kind of add-in product. I think we'll skip over this. Then they have this other example, which I wasn't able to find. I don't think the book gives us this data. So then they've got a few other. I think we're done with this chapter. So this is chapter 1. This is our very first introduction to statistics and statistical methods. We've already had a chance to do our first spreadsheet, which is kind of cool. And we also have learned a lot of key terminology. Now, I do want to point out that the very first MindTap assignment, which will be due next weekend, is based on what you're seeing here. I think that might be all that's, let me go back here. Okay, I guess we can put this away. I'm pretty sure I have it open. God, I've got so much stuff open here. Maybe not. I'll just reopen it. So if, yeah, hold on. By the way, your setup might be slightly different than what I'm seeing on my side. I just want to mention that. It probably is organized a little differently. All right, here we are. And if you look carefully, I do want to point out one important thing here. When you're looking at the assignments, there's a lot of activities here that are not required for you to do, that are not being collected for grading. And so it's all kind of jumbled together. What I recommend you do is use this little calendar rolling week view to find your assignments. And you'll see that in what's they're calling week 2, meaning it comes to an end this coming weekend, you've got, these are the assignments right here. Okay. And you'll see most of them involve Excel, but they're all based on what we just did here. And they sometimes try to give you a rough idea how long they might think it might take, but I'm not sure how accurate that is. So these are the ones you'll want to do this coming Sunday, and already you have enough background to do them. So if you wanted to, you could start them right now. There's nothing to stop you. They're all open, but what separates them all is when they're due. Okay, so that's that. Now, what I'd like to do is show you what's coming next in chapter 2. And by the way, most of these chapters are not quite that short. That was our first introduction. This is chapter 2. It's fairly long. And we're going to look at other ways of organizing our data. We're going to learn more Excel. And we're also going to start looking at numerical summary measures of our data. So in other words, our job in this chapter is to learn how to draw conclusions from our data. So anyway, I guess we can stop right here, and next time we'll start with chapter 2. All right, so I'll see you then.